Alaikum. Okay, now guys, this is the book that you guys are using. Okay, so I wanted to show you the solutions of some of the questions from this exercise 3A that we have just discussed. That was resolving forces. So I have exercise 3A in front of me. The first question, it says resolve, find the components of the forces in these diagrams. I've just copied down these diagrams from the first questions parts of this exercise 3A. So now this is the first part, you see, as I told you. Now this is a force of 15 newtons inclined at an angle of 40 degrees. Okay, so if I want to resolve this in its horizontal and vertical components, so you will see that this would be 15 cos 40 and this one is 15 sine 40. So this is vertically upwards, this is horizontally towards the right side, going towards the right side. Okay, similarly you can see this second part. So this is going towards the second quadrant side. So this is going to be resolved like this. This component is 12 cos 55 and this component is 12 sine 55. Okay, similarly in the fourth part you have now this is going towards the fourth quadrant direction. Okay, the thing is that you have to have a right angle triangle sort of a situation so that you can have a horizontal and a vertical component. Okay, so this one is its magnitude was given, the fourth part, yeah, that is 21 newtons. Okay, so this one is towards the right side, its horizontal component is 21 cos 70 and this one going downwards 21 sine 70. Similarly this one over here, so like normally people think that whenever you have a vertical component there will always be a sine with that, and with the horizontal component there will always be a cos with that. But there can be cases like this. Look at this, this is the vertical component over here, so this is not necessarily it has to be with the sine thing. So this is going to be its vertical component, downward vertical component is going to be 80 cos 65 and this one is 80 sine 65. You see there is a sine with the horizontal, so we only have to see that this is the angle and this is the opposite side. The opposite side of the given angle has to have the sine thing with it. Okay, now for this one, this is really a big angle, 175 degrees going towards the third quadrant. So there are two options with you. Either you can have it like resolve like this angle is 5 degrees, so this is going to be 8.5 cos 5 and this is going to be 8.5 sine 5. Some of you might like to resolve it in this way, like if this is 175, so this angle is going to be 85, so this is going to be, let me use a different color here, like this can be 8.5 and this is cos 85 and this one is 8.5 and this is sine 85. Okay, so these are the sum of the parts, the first questions. You can do the rest. Okay, then I'll be taking you to the third question. Now this third question is really a special one. This takes us further into this topic. Now this question purely deals with the equilibrium situation. So it says a particle in equilibrium has three forces of magnitude, all these like F, 5 and 6, and they are acting at the given angles. So we have to find the values of F and theta. Now guys, remember you will have to be very good at your P1 trigonometry to find the values of these unknowns over here. Okay, so first of all, these are obviously three forces. There are two inclined forces, one is a horizontal force. So we have to resolve these forces first of all. Okay, so I'll be resolving this. This F is going to be, this is F sine theta and this is your F cos theta. I would like to resolve this force in this way so that I can avoid the overlappings happening over here. This is 70, so this is your 70 degrees. So this is 6 sine 70 and this one is 6 cos 70, and we don't need to resolve this because this is already a horizontal force. Now guys, when we are given that all these forces, I mean this particle which has these forces acting on it, this particle is at equilibrium, so that means the resultant of these three forces is 0. Your acceleration is 0. Like if you just see this, if you recall that F equal to ma thing, so here this acceleration is 0. So if you remember, this F had to be the resultant of the forces. So this means this side is 0, so the resultant, that means your R is 0. When your R is 0, so this would imply that Rx is 0 and Ry will also be 0. It is a vector like this, 0, 0. So obviously when the column vector is 0, 0, so that means the magnitude is going to be 0. So we are given that the magnitude is 0. So we're going to put this Rx and Ry equal to 0 over here, okay? So look at this now. This is the Rx with me. I hope you can see this. Rx is going to be F cos theta plus 6 cos 70 and then minus 5, and I'll put that equal to 0. Okay, so by using the calculator, I'll have this. This is 5 minus 6 cos 70. So this F cos theta is 2.94788. Okay, similarly I'll be finding Ry. The Ry would be this F sine theta upwards and minus this 6 sine 70. I'll be putting them equal to 0. So I'll get this F sine theta. It's good to have their exact values, but I'm just not following that rule here. Just finding these values. This is going to be 5.6. I'm writing this to a good number of decimal places so that I can stay near to the as near as possible to the exact answer. This is the first equation, this is the second equation. We'll be solving these two equations simultaneously so that we can find F and this theta. So let us divide these two equations side by side. So by dividing them side by side, I have F sine theta over F cos theta, that is equal to 5.6382 over 2.94788. Once I have this F is cancelled with this, and this will be giving me tan theta equal to this, you will get your theta. So if you have this theta with you, you substitute your theta into any of these two equations and you will get the value of F. Okay? So just trying to keep your this video as short as possible. So there's a really very relevant question. I really wanted to do that at the fourth question. Okay, so you please try these first 5 questions. In the next video I'll be taking you to the questions beyond this 5th question, and they have application of that f equal to ma more over here. Okay, so thank you very much. So see you in the next video then. Allah Hafiz.